So good afternoon, good morning. So this is us. We're Waugh Thistleton Architects. We are an architects practice based in London, in the UK, and we design and build and research in timber buildings. So I'm going to start with a graph, but don't worry, there won't be many of them. So the reason why we started first working in timber was about sustainability, was about carbon. Now, if in the UK, we measure the carbon of a building, the carbon use of a building over 50 years. So, and over 50 years, at the very beginning, it's all about the building materials and all about the construction process. That's 100% of the building's carbon when it starts. But as the building is used, the energy that goes into lighting and heating and even sometimes cooling the building is actually, by the time you get to 50 years, is the majority of the carbon that that building uses over its notional lifespan. And the materials and the construction process, just under half. But actually we don't have 50 years. And our argument is, our position is that actually we have 17 years to meet our Paris targets. And if you push this back here and you understand that the building materials and the construction process are actually over 2/3 of the building's carbon footprint, then that's what we need to be addressing now, because we can't wait 50 years. We need to be doing it right now. So there we go. Oh, I'm very bad with these, always. There we go. So as Marcello was saying, we use predominantly cross-laminated timber. And did we explain exactly? So cross-laminated timber is really, it's a fabulous material because it's so simple. It takes the cheap material from the outside of the trunk, the stuff that's made into paper or chip for fuel. It takes that, we turn it into planks, we spray it with a water-based adhesive. So very light adhesive, less than 1% of the volume of the panel is adhesive, no formaldehyde or anything. And it's cross-laminated, so you build it up in perpendicular layers into these massive panels that go into the factory. And you can see here, so they come out of the factory sort of 30 meters long by 3.5 meters wide. You cut the windows out, you cut the doors out. There's a roof profile there. So everything's cut out on a CNC machine after the panel goes through the factory. Now, in 2003, which was a long time ago, we were a much younger and smaller practice. And we began to talk about notions around sustainability and just an understanding that perhaps double glazing wasn't enough to save the planet. And so we built our first building in 2003, the first CLT building in the UK, this tiny little building, 45 square meters. Big, small, 45 square meters small. Why it always works for you, Marcello. So 3 stories, tiny little thing, 3-story building. And I sat in my car on a Saturday afternoon and I watched 4 people put this building together. So these panels arrive on site on the back of a truck. They're craned in by a mobile crane and put together with a cordless screwdriver. So we sat there and watched this amazing process happen. And I was just completely in love with this notion of building. Because, you know, what I drew, and I don't know if there are many architects here, but what I drew on my machine is exactly what arrived on site, plus or minus 2 millimeters. So that very kind of rudimentary material is actually involved in a very sophisticated process, if you like. So what we are drawing in our CAD programs is exactly what's arriving on site. So I fell in love not only with the notion of actually being able to build with a material that was made of carbon, so would be a carbon store, but also with the kind of process of design to construction. It was a nightclub for classical musicians. I've never been back. Okay, so in 2008, so between 2003 and 2008, we built a few houses, a few roof extensions, a table. You know, we kind of like really beginning to understand this material. And what I think we began to get hold of was a notion that, you know, if you account for architecture as a political action, you know, primarily a political action in the sense that you are dealing with the problems of the day. You need to grapple with, you need to assume the problems of your age, of your generation. So the problem of our generation, of my generation of architects in London, really is about urban densification and climate change. How can we provide civilized, humane buildings for our population without exacerbating climate change, without actually adding to the problems of carbon emissions? So I had an idea that what we would begin to do is to think about high density, medium, high-rise buildings, but made of timber. And so every project that we got into our office that was, you know, that was a high-density housing project, I'd design it, and then I'd sit down with the client and explain to the client how we were going to help save the planet by building the building out of timber. And the client would say, no, you're not. So then after about 5 years, we began to really kind of hone this argument. You know, we began to get a clearer understanding of how we might produce these buildings. We made this building in Murray Grove, Stat House, 8 stories, a 9-story building, 8 stories in timber. And we did it with a solid timber honeycomb structure. So every panel in the building is working. So timber lift shaft, timber staircase, timber floors, timber walls, and everything screwed together and working very hard. So 9 stories, 29 apartments. And you can see, I think here in this photograph, really simple. So the whole building is put together with, I don't know, do you say millimeters or centimeters? Both. Okay, 75. So it's a 75 millimeter angle bracket with 100 millimeter screws. So really straightforward. So we built this building, 4 people built this building in 27 days. So, and they did that, and you can just see really simple details. And also here, you know, in the ceiling here, you can see this is where all the electrics, all the services run in the ceiling. And the electrician explained to me when he was on site, you know, they wear stilts. Do they wear stilts here? Anyway, they walk around in stilts. So you're on site and the electrician is up here. And the electrician said to me that in the UK, when you apprentice as an electrician, you spend about the first 18 months drilling into concrete. And then after 18 months or so, your shoulder joint disintegrates. And when your shoulder joint is disintegrated, then they teach you about electrics. And he said, this is fantastic. I could wear a suit to this job. So anyway, so they were on a 9-week program. They were there for 10 days, fixing in, and then they all went on holiday together. But this is, so it's really simple. So we built this building in a very simple way. Because we were doing something that hadn't really been done before, we thought we'd keep it incredibly simple. So you can see it's a platform construction. So the wall, the floors, and wall on top, floor on top. So just built up very, very simply. So you have 146 millimeters of slab, 128 millimeters of wall here. You've got we laid a screed, so a resin-based concrete screed about that thick, and we put underfloor heating in there. And we did that for acoustic mass and for thermal mass in the building. And so here we are. This is you can see the construction site, a mobile crane. So these are the staircases, lift shaft. And we saved over 1,000 tons of carbon dioxide from going into the atmosphere just by building this building in timber, which is over 220 years of building regulations in the UK. So we were able to go to the council and say, well, we could do that for 1 year, or we could do this for 220 years worth of the same thing. So much reduced foundations as well, much lighter building. So much less concrete in the ground. So we finished this building in 2008, less waste because it's prefabricated. So completely quiet, no jackhammers, no grinders, no cement mixers, and far fewer deliveries. So we would have had, you know, 400 or 500 deliveries of concrete with this building. And in fact, we had less than 100 deliveries of timber to build the entire building. And lightweight, so 1/5 of the weight, so reduced foundations, etc. And now every summer, I stand here. Every September, I stand here and I do a talk outside the building And when it's sunny, we get a lot of people. When it's raining, not so much. But when it's sunny, we get a lot of people. And a couple of years ago, it was really sunny. You know, it's like 20 degrees. And, and I stood here talking about the building. And there's a guy who lives here who has a parrot. And the parrot sits there. And the guy leant out of the balcony. And he was shouting things down when I was talking. And he was shouting things down like, I've never used my heating. And I can't hear my neighbors. And really helpfully, it's all made of wood. So, I'm not sure which slides. So that's it, finished in 2008. In fact, the timber went up, started to go up 10 years ago this week. So it's a really exciting anniversary. And everybody in my office is celebrating without me. So, and as Marcello was kind enough to show, in 2012, I bought a piece of land with my friends, Jason and Dan and me, and I live here. It's my house. I was going to live there, but then Jason fell out with Dan, and Dan didn't want to do it, so then I moved there, and anyway, so we're all good now. And then Jason moved to Sao Paulo. So now Jason lives in Sao Paulo, but that's another story, it's coincidence. So we bought this piece of land, we sold our apartments, we sold our cars, I sold one of my children. We bought this piece of land here, and then we sold this floor here, and we really didn't have any money at all. And then we sold this floor in the middle here, and we sold it to a photographer, and the photographer said, I need a space for my particular camera that is 6.5 meters high and 9.5 meters wide and 23 meters long with no columns and no beams. So all the lessons, if you like, all the structural understanding that we got from Murray Grove of this idea of a honeycomb was gone because we had to have a massive open space. So what we began to think of was to begin to understand, or to begin to try and understand, what this material might be able to do. Now, because of the cross-laminations of the panels work as a deep beam. So if you like the panel, a long beam like that, a panel can take a load here and can carry that load along. So what we did was to use the walls between each one of the apartments here, we use those as deep beams. And those beams hold the floors, here and here. And then the beams are supported by a big truss, which is the front elevation and the rear elevation. So what we were doing was to use the incredible strength and lightweight nature of the structure in order to be able to create the architecture. And what we began to get a sense of was actually that if you use a new building material, then from that new building material, you begin to understand a new architecture. So what we began to realize was that this was an opportunity not only for a sustainable kind of construction, but also an opportunity for a new kind of architecture. So this, you can see the building here without the cladding. So that's my sitting room. That's where I live now. And that's the photographic studio, the offices, etc. And then in the winter, the first winter we finished. And in 2016, I took my whole office up into Austria, into the mountains where most of our trees come from, and we went and we met lumberjacks and we cut trees down with them, and we went to the factory, and we all kind of sat around, and we went to a CLT factory, and we got incredibly excited about this. And we sat down as a practice, and we decided that from now on we were going to be 100% timber as a practice. And what that means is that every building that comes into our office, we design as if it's going to be a timber building. Because what we realized is that our lexicon of imagery as architects, all the buildings that we know and understand are all concrete buildings. And if we're to begin to change the architecture we produce, we need to begin to conceive of those buildings as timber buildings, not concrete buildings. So last year we built a massive building in CLT. And this is a very important building to me because of the high density that I was talking about before, high density housing. So this would have weighed 10,000 tons in concrete, weighs less than 2,000 tons in timber. Over 7,000 tons of carbon dioxide from going into the atmosphere just by building this building in timber. So it's 121 homes, 4,000 square meters, 16,000 square meters, 10 stories. The entire structure was built in 5 months by 12 people. 4,500 cubic meters of CLT, 2,325 trees, and 800 people now live and work in that building, which is less than 3 trees per person in the building. And it's about the same amount that you use every year in terms of your paper use. So there's not a lot of trees. And you can see this building. Maybe I'm fiddling with the batteries. So this building here, this is the building going up here. You can see 10 stories all in timber here, there, and then the building clad in brick, 10 stories finished. And you can see how fast it was as well, because by the time the train has gone, the building's finished. So that's it, finished in November last year, and everybody now living there and moving in. Now I want to talk to you about where we are now as a practice, what we're now doing. We are now beginning to think about other kinds of timber. So using hardwoods as well as softwoods, using LVLs, which Martillo was talking about before, and introducing things like Kevlar and carbon fiber into the joints that we're working with. So this is a factory that we built just recently in the north of England, and we're using LVL beams here for the timber. So that's a 25-meter span at 400 millimeters or 420 millimeters deep as a beam. So as strong as steel, but much, much prettier. So here you can see this is a factory. Well, it's a factory down one end and then a ballet school down the other. So it's a different kind of building. Completely naturally lit as well, which is really beautiful. And we're working on a cinema, so this is a 3-screen cinema here at the base and 5 stories of residential above. We're working on a number of projects where we have existing concrete buildings, and we're using the existing concrete to provide the shear capacity in the building. And then on this one, we're building 2 stories on top, and we're building out the back and out the front. So it's about 5,000 square meters. And we build in the snow. So when all the concrete people have gone home, because it's a bit too cold, the timber people keep building. That's great. This is some hybrid. So we've got some hybrid systems now as well, where we're using some steel. So this is steel in the building, in the office floors, and then a CLT core and CLT floor slabs. So this is 5,000 square meters, and the entire building will take 10 months to build. Again, very quiet as well. I live just down the road, so it's important. And this is what it will look like finished on the canal. We now have projects further afield, so we're working in Paris, and so this is 68 apartments in Paris. We've got 2 projects in Paris, a couple in Singapore, and then Madrid. So we're really beginning to spread our wings. We're working for the American government. I work for Trump. Doing a research project into timber construction, which is incredibly exciting. We're working with Shigeru Ban. So this is a building here we just got planning consent for with Shigeru Ban. This is the mayor's office here. So the mayor will look down on our building and get inspiration here. So this is a fabulous project. For me, this project, it's a bit like going back to college, because he's obviously a very, he's a genius. no getting away from it. And he's so actually for me to learn and be learning with this architect has been an incredibly enriching experience. And we're doing things like on this building, the joints of the building, the way that the beams and the columns are going together is by using a hardwood dowel into the joints of the beams. And how they do that is they get the hardwood dowel and they put it in a microwave. So the microwave for about 5 seconds, and it takes all the moisture out of the dowel, and then when it pings like that, you take it out and you put it in, and then it takes all the moisture and is solid. And I went to a building site of theirs in Switzerland, and the whole building site's full of microwaves, and they're just going ping, 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 ping. It makes you really hungry. Quite hungry now. So one more graph. So I want to talk to you about productivity, because one of the things that we've realized that when you take out one building material and you put in a different building material, the architecture is definitely affected. The architecture has the opportunity to change and to grow and to adapt. But also, so does the way that people work on site. Now, one of the things we know is this is a graph about productivity in construction in the UK. So in the UK, productivity in construction, since the birth of the digital age, has gone up by about 1.5%. But in the rest of manufacturing, it's doubled. So in the last 100 years, in fact, productivity in construction has gone down by 5%. So now, in the UK, we make buildings more slowly and more expensively than we did 100 years ago. So if you think about that, the car manufacture then, 1870s, and today with Nissan in the UK. And then with the advent of the anesthetics in the 1890s, keyhole surgery today. And then construction then, and construction today. And you begin to think, what are we doing here? We're supposed to be modernists. So we're working with CLT Modular Housing Factories. So at the moment we have 3 different projects working with factories, working with assembly plants, looking at how we can use timber-engineered panels in order to provide manufactured housing, to get the kind of quality, to get the kind of change in the construction industry that's really only possible through manufacture. So we're working with this one factory, 6.5 hectare factory, 5,000 homes a year, prefabricated and delivered to site. Now what's really interesting about doing this from cross-laminated timber is that a factory works by repeating the process, so the same thing again and again and again. But if you are cutting a panel, if that panel is going through a machine, as long as it goes through the machine in the same way again and again, that's fine. But actually the file that controls what is cut from that panel can be different every time. So you can repeat the process, but you don't have to repeat the product. Now that means that we can build completely different buildings. Every box that goes through can be completely different. So those buildings are arriving on site, kitchens and bathrooms installed, and we can begin to talk to the people who are going to live in those buildings and say to them, what kind of bathroom would you like? What kind of kitchen would you like? What color would you like your bedroom? But we can also begin to say to them, how many bedrooms would you like? What should the outside of that building look like to you? So we can actually really begin to involve our clients in this notion of choice. And so that for me is something that we have lost in architecture. So often we are so divorced from the people that we're actually providing the homes for. Now if you think about the car industry, in the car industry, this is a Mitsubishi, that was a Mitsubishi, that is a Mitsubishi GS platform. So that's one chassis which provides 14 different cars. If you buy an Audi A4, you have over 1 million choices when you buy an Audi A4. And yet in architecture, what we do, you know, when we provide somebody with a home, is we often provide them with a kind of sufficiently mundane product. You know, the white box that nobody's not going to like, but do they really like it? So what we're going to do is, what we're doing at the moment is doing prototypes with these 3 different factories, lots of different prototypes, and we're learning about what the design parameters are for building with modular. And what we've worked out is actually you get the postcode, and the postcode says how big the truck can be that gets to the site, and how big the truck is will say how big the box can be, and then how big the box is will actually begin to inform the architecture. So we are on site with this one at the moment. This one starts at the end of April, so 7 stories, 6 months, and the whole building will be finished. 65 apartments. And we're looking at larger projects. We have another project just starting, which is 25 stories in South London. And so this journey for us as a practice that started with low carbon buildings, started with the idea that we needed to be more careful, understand more holistically the implications of our actions as architects on the environment, and to work not with materials that we scrape from the surface of the planet, but to work with materials that we can grow more of. And that we realize that these buildings could be healthy buildings, that they are healthy buildings, that it's demonstrated that people who live and work in timber buildings, that work in a natural environment, are happier people. You know, they sleep better, they're less stressed. Children who are educated in schools made of timber, their heart rates are lower. I mean, this is really, you know, these are really important issues that we kind of really just beginning to come to terms with. And also understanding that even though our cities are densifying, that we can also encourage rural economies so that we can work with people in the forests. And that these are beautiful buildings. They're firm, functional, delightful, they're solid, robust buildings, buildings that we really can feel at home in. And that we're also introducing into these buildings choice. So we're repeating the process, but we can introduce choice into the architecture that we're providing. And so what we see this as is not just a change in a construction material, but an opportunity for a complete construction revolution, to completely rethink the way that we design buildings, rethink the way that we construct buildings. And this last slide is not that one. The last slide, this is the number of tree seeds that took to grow the trees that built Murray Grove. Thank you.